Okay, so onwards to our second video, right? So the first video we have seen about Huffman coding. Now we are going to go through the second one, which is on Elias coding, right? So if Huffman is for characters, right, A to Z, ASCII of 0 up to 255, Elias is going to be used for numbers. Okay, so let us begin. Okay, so if you were to hold at your leisure sites, blah blah blah, a lot of words, yaga yaga yaga, right? As usual, I'm going to explain it in my own way. Okay, if I want to save a number, right, a decimal number, I shouldn't use rate, right, a decimal number. What is the range of decimal numbers which you're able to save in your computer? Okay, so you're going to realize it's actually 2 to the power of 7 minus okay, assuming if your machine, right, is actually a 32-bit machine, right? If you want to avoid overflow, it's going to be 2 to the power of 31 minus 1 all the way to 0, all the way to 2 to the power of 31 plus 1. Okay, why is it 2 to the power of 31? Because 32 bit means I'm going to have, right, 32 bits, right, and here will be 31 bits, right. The first one is for the sign, right, so here will be negative and here will be positive. Okay, so here is how you can encode numbers. Okay, the problem is, imagine if I want to save the number 3, right? Number 3 in decimal, I know binary is 1 1, so I'm going to allocate all 32 bits, right, and the only thing which I save is 1 1. Then it will be 0 0 0 0 0 0 0 all the way, because it is positive, it will end with 0. Right, if I want to save negative 3, right, it's going to be the same, right, except the n is 1. And you realize, instead of saving 2 bits, I'm risking 29 bits, right? So once again, do not be a noob. You're wasting a lot of memory. Okay, so we are going to want to do something which is like our we are going to do something like our Huffman coding. Okay, the problem, we have seen the concept from Huffman coding, right? We want it to be prefix free, right? And for it to be prefix free, we need to build a binary search tree. Okay, but unlike characters, which is 0 to 255, your numbers can be a big range, right? From negative 3,769 to 420 to 332, right, and so on. You're going to have a wide range of number. So imagine how big will your tree be if you want to build a prefix free tree. Okay, so what I'm going to show you now is what we call the Elias encoding, right, or Elias coding. Okay, so imagine I have 2 numbers, right? So instead of me choosing the numbers at random, I'm now going to choose the number here, right? Let's say I got 5 numbers: 1 to 3, 100, 123, and 56, right? So I've already copied it at the side, so I can go to the whiteboard and do it easily. 1 to 3 base scan, 100 base scan, 1 base scan, 23 base scan, and 561 base scan, right? If I were to convert everything into binary, it's going to be 11110112, then it will be 1100 2 1 2 101112 and 1000110012. Okay, so imagine the following, right? If I give you a combination of bits, right, let's say it's 1 1 1 1 0 1 1 1 1 1 1 1 1 0 1 1 1. Okay, we are going to suffer from the same problem, right? Am I supposed to slice it in such a way, right? 1 1 1 1 0 1 1, right? And I know the number is 1 2 3, or am I supposed to slice it as the following: 1 1 1 1, right? You're going to come across an issue because you do not know where to slice. When everything is 32 bits, you can slice 4 bytes, 4 bytes, 4 bytes, 4 bytes, 4 bytes, right? But here we are going to suffer the same issue. Okay, so the concept of Elias coding is very simple. What you see here is the binary representation. So if you use binary of 1 to 3, you're going to be given 1 1 1 1 0 1 1, right? But note, if you use the Python binary, you're actually getting a string, which is 1 byte, 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 right? So this is the bit string. If you use the built-in binary function in Python, you're going to receive a bit string. It's not what you want, right? So yes, you can use the binary function, but I will not recommend it, right? Because when you use the binary function, what you're receiving is a bit string, not in binary. So you're actually wasting a lot of memory. Okay, so what you want is you want to do the 1 to 3, right? Divide by 2. Divide by 2 will be 61 with a balance of 1. Then divide by 2 will be 30 with a balance of 1, 15, 0, right? Then you go all the way up. Okay, so yes, you can use the built-in binary function, but the built-in binary function is a bit string, and because if you use a bit string, I could not have the marking rubric yet. I could not have a marking scheme, right? So there's a chance you may be losing marks if its scheme could be inefficient, right? So in my words, please do not use it, right? And use the following thing here, right? This is what I would recommend you to be using. Of course, use it as your own risk because you're growing up. I cannot force you, but I can always minus your marks, right? Okay. So the first step is we want to obtain the binary representation, right? Remember, binary, not bit string. Then we want to prepend with additional bits. How am I supposed to prepend with additional bits, right? So for example, if my binary is 1 1 1 1 0 1 1, and I want to prepend with 0 0 1, right? No, I want to prepend with 1 1 0. Okay, so if I want to prepend it, it's actually quite straightforward, right? Here I got 1 2 3 4 5 6 7, right? Means I need to shift this number 7 places to the right. So if I were to save it, shift it 7 places to the left. So when I shift it 7 places to the left, I will get 1 2 3 4 5 6 7. Then I perform a OR operation, right? So if I want to perform a OR operation, let's just copy. Then it will be 4 ones, right? Right. So I perform a OR operation 1 1 0 1 1 1 1 0 1 1. Right, so this is how you're supposed to operate in binary, right? Shifting to the left and using an OR operation. Okay, so if you want your assignment tree to be very, very fast, right? Could be very, very efficient. As I mentioned, if you use the built-in binary function, I can't guarantee you may or may not be penalized because I do not have the marking rubric yet, right? But knowing our rule, if there's a faster way, it's always safer to use a faster way, right? So what is a faster way? 1 2 3 is already stored in your memory as the form of a binary, right? So if you want to prepend, you shift what you want to prepend to the left and you perform an OR operation, right? So you can search how you want to operate it. Okay, what are we going to prepend, right? What we want to prepend is actually the length, right? So I'm going to show you the set one by one now. 1, 2, 3, base scan is 1, 1, 1, 1, 0, 1, 1, 2. Okay, how many bits do I have? 1, 2, 3, 4, 5, 6, 7, right? So here I got 7 bits. Okay, so because here I have 7 bits, I'm now going to look at 6 to the power of 10. In other words, I will minus 1. Right, what is the binary of 6? The binary of 6 is 1, 1, 0. Okay, and here I'm going to have 3 bits. Okay, then I will minus 1. I will be left with 2. 2 will be 1, 0. I'm going to have 2 bits. Then minus 1 will be 1, 10, which is 1. When I reach 1, 1 minus 1 is 0. I terminate here. Okay, so what you're going to see here is the following in the end. Right. Okay, so this is what you're going to see for 1, 2, 3. Then we are going to prepend the bits here with everything here. Okay, you notice my number always begin from 1. Right, my number always begin from 1. Okay, my number always begin from 1. But what you see here is actually the length, right? Remember here the length of 7 is the length minus 1. Okay, so because of that, right, length and the actual number is different. If all of the numbers begin from 1, I want the length to begin from 0, right? So here will be 0, 1, 0. Here will be 0, 0, and here will be 0. Okay, so the encoding of 1, 2, 3 will be 0, 0, 0, 0, 1, 0, 1, 1, 1, 1, 0, 1, 1, 2. Right. Okay, so if I were to encode 1, 2, 3, it's going to be 0, 0, 0, 0, 1, 0, 1, 1, 1, 1, 0, 1, 1. Okay, and I will show you how to decode it afterwards. Okay, the same concept apply. Okay, so now let's use blue. Onward base scan will be 1, 1, 0, 0, 1, 0, 0, 2. Here I got how many bits? 7 bits. So 7 minus 1, 6 base scan will be 1, 1, 0. Here I will have 3 bits. 2, 10 will be 1, 0. 2 bits. 1, 10 will be 1, 2, which is 1 bit, right? So here is where I'm going to write 0, 1, 0, 0, 0, 0. Then I will prepend it as 0, 0, 0, 0, 1, 0, 1, 1, 0, 0, 1, 0, 0. Okay, so I'm going to do the same for each and every one of them. Right. So what about 1? Right, 1, 2 equals to 1, 1 of 10 equals to 1, 2, right? Because L minus 1 is already 0, I terminate. I do not need to prepend. It will only be 1. Then the next one will be 23. Base scan will be 1, 0, 1, 1, 1, 2. L will be 5. 5 will be for base scan. Will be 1, 0, 0 base 2. L is 3. 2 base scan will be 1, 0, 2. Then it will be 1, 10 will be 1. Then flip everything 0, 0, 0, 0, 0, 0, right? 0, 0, 0, 0, 0, 0, 1, 0, 1, 1, 1. Okay, and the last number is 56 base, no, 561. 561 to the base of 10 is 1, 0, 0, 0, 1, 1, 0, 0, 0, 1. How many bits do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in total I have 10 bits, so 9 base 10. 9 in binary will be 8. 0, 0. 8 is 2 to the power of 3, right? Then it will be 4, means it's 3 base 10. 3 is 1, 1. Then it will be 2, means it will be 1, 10 equals to 1, 2, means I'm finished. So it will be 0, 0, 1, 0, 0, 0, 1, right? So if I were to write it out, it will be 0, 0, 1, 0, 0, 0, 1, right? And finally, I'm going to put what we see here, 1, 0, 0, 1, 1, 0, 0, 0, 1. Okay? Now imagine if I were to randomly combine all my bits, right? So let's say I begin with the 1 here first. Okay, I begin with the 1 here, then I follow up. Oops. Then I follow up with the 1 here. Okay, then I put in a 1. Then the last one, let's say I follow up with, yeah. Okay. Imagine this is my input, a long bit, not bit string, right? So if you want to implement it very fast, it will just be a concept of shifting. So if I have a pointer and I want to move my pointer, I will always shift left, right? So my pointer doesn't move. Let me show you an example, right? If I want to move my pointer over here, I do not move my pointer. Let's say this is X, I will just go X, shift left by 1. So what happens when I shift left by 1, right? I shift it, shift it to the left by 1, right? If I were to shift it, should I use a left shift or should I use a right shift? Yeah, a right shift is going to be much easier. Actually, both is fine. It depends how you implement your pointer, right? So, how am I supposed to manipulate my pointer? So, a way to manipulate your pointer is, there's actually some logical operation where you can use your OR, where you move your pointer as well. Let us not go into the wormhole, right? So figure out a way for you to move your pointer efficiently. Okay, it can be either by shifting or using some form of operation like saw, some of your logical operation. Okay, so here, for my explanation, let's assume it's a bit string. Right. Let's assume it's a bit string for now. So if you have issue operating in binary, my recommendation is operate it as a bit string. Okay. So I'm going to begin from here. The number is 0. If the number is 0, means it is the length. Right. It denotes the length. So if the is 0, right, I flip it, it will be 1. Right, 1, 2, if I convert to base 10, it will be 1 base 10 plus 1 is going to be 2 10. So it's telling me the next combination will be 2 bits. My next 2 bits begin from 0, means it is still a length, right? So I will flip it. I will flip the first bit. 1, 1 in binary will be 3 in base 10, right? Because you remember just now when we encode, we perform a -1, right? We perform a -1 plus 1, so it will be 4 base 10. Means the next 4 bits, right? The next 4 bits begins from 0, right? The next 4 bits begin from 0, means it is the length. Flip the first bit, 1 0 0 1. 1001 base 2 in decimal is going to be 9 base scan plus 1 will be 10 base scan, means I will look at 10 bits 1 2 3 4 5 6 7 8 9 10. Okay, I begin from 1. Because I begin from 1, I know it's a number and I realize it is 561. Okay, so everything here is going to give me 561. Okay, then my pointer will now be here 0. 0 means it's the length, flip it, right, convert to decimal, plus 1, 2 means the next 2 bit. My pointer is here. The first bit is 0, means it is still denoting a length. Because it denotes a length, means what? It denotes a length, right? So if it denotes a length, means flip it, right? Convert to binary means it is 2. 2 plus 1 will be 3, means I will look at the 3 next 3 bits. Begin from 0 means it is still the length, it will be 110 binary, right? Convert to decimal will be 1 to 4, it will be 6 base scan, plus 1 will be 7, 1 2 3 4 5 6 7. It begins from 1, means it will be 11001002. Convert to decimal, I'm a bit lazy, right? Decimal is 100, means here, right? The pointer was here is going to be 100. Okay, then the next one, the pointer will be here. The pointer is 1, means it is a number, means here is automatically 1. Okay, it will be 1. Okay, then my pointer is here because it is 0, means I flip it 1 2, means 1 10, plus 1 will be 2 10. Look at the next 2 bit, begin from 0. Because I begin from 0, it's going to be 10, right? Convert to decimal will be 2. 10 plus 1 will be 3. Look at the next 3 bits, right? Pointer will now be here. It still begin with 0, means it denotes the length, right? If it denotes the length, it will be 100 base 2. Convert to decimal means it will be 4 base 10 plus 1 will be 5, right? The next 5 bit. Then my pointer is going to be here. My pointer is pointing at 1, means it's a number 1011. 11 in binary will give me a decimal of 23, means everything here is going to be 23, right? So this is how you see I actually decode it. Okay, so EliasCoding is quite simple, right? The concept is length begin with 0 bit, okay, and then number begin with 1 bit. Okay, so you will use the length to know where are your slices, right? Let me use a blue, right? Length number, right? But it tells you the next scan bits, right? The length of the next slice. Then you always begin from here, right? Next slice, right? Because it begins from 1, it is a number. Begin from 1, just a singular number. Slice, and so on. Okay? How am I supposed to represent 0? Okay, I will come back to it afterwards. So if you look at your slides, right? If you look at your slides, blah blah blah. Once again, if you look at Lampersive, all of the numbers which you see here is going to be Elias. Elias of 1, Elias of 3, Elias of 4, right? Let's use 3 for example, right? So if I want to encode 1, 3C, okay? So what you're going to see here is this will be Elias, This will be Elias. Here will be Ahmed. Okay, so let's assume the Ahmed of C is, let me just assume Ahmed of C is 0, 1, 0. Just assume. Okay, so how am I supposed to encode it? Okay, so let's begin with 1 base scan is 1 binary because it's 1 and gun, so the first encode is going to be L. 3, how am I supposed to encode 3? 3 base scan is 1 binary, here the length is Q, 1 base scan will be 1 Q, means I'm gun, here I flip it, right, so it will be 0, 1, 1, right, so encoding of 1 is 1, encoding of 3 is 0, 1, 1, and finally my Ahmed is 0, 1, 0, right, which is what you see here. Okay, so to encode 1, 3, C, right, how I encode it will be 1, 0, 1, 1, 0, 1, 0. Okay, so I know I have two numbers, right? So if I know I have two numbers, I will begin my pointer from here. If my pointer is 1, means it is 1, right? We have seen earlier. Then I begin my pointer from here. 0. Because it is 0, I know it denotes the length, right? So flip it will be 1 binary, which is 1 decimal plus 1 will be 2 decimal, right? I look at the next 2 bit, pointer is here 1, means I know its number. 1 binary will be 3 in decimal, right? So I know here is 1, here is 3. Then I slice. Number, next one is going to be alphabet. So assume I've already have a binary search 3 for my Ahmed, whatever, right? So it will be 0, 1, 0, 1, right? Then it will be 0, it will be 1, and it will be C. Right, so when I traverse, it will be 0, 1, 0. Then I reach the alphabet C. So I'm able to decode it as the following. Okay, so when you look here, right, all of the numbers which you see here is going to be your Elias. Okay. But what about 0? How the heck am I supposed to encode 0? What about here? Right? So if you were to see here, right, you realize my smallest number is 1. Right? Which is what you see here. So if I use Elias begin from 1 all the way to infinity. Right? Inclusive, exclusive. So your Elias is not able to represent 0. It's not able to represent negative number. So imagine if I want to do Elias of of 0 all the way to infinity. How am I supposed to do it? Right? So what is going to happen here is, right, when I receive 1, I will minus 1. Right? Because if my Elias have a minimum of 1 and I want the new minimum to be 0, I will always minus 1. So here, right, 0, 1, 1, which used to give me answer 3. If I minus 1, it will give me 2. Right, so what you see here will be 0, 2, C. Okay, now what happens if I were to write a negative number? Let's say from -1 all the way to infinity. The difference between 1 and -1 is 2. Right, so I will now minus 2. Right, so 1 minus 2 is -1, and here 3 minus 2 will be 1. Right, so my entire encoding here will be -1, 1, C. Okay, so it's just a matter of shifting your Elias encoding to the smallest possible numbers. Right, so with that, right, I can denote here as -1. Oops. I can denote what you see here as -1, and I can denote what you see here as 1. No, -1 and here is 0. Okay, so this is a way where you can use your Elias encoding, right? You shift the scale. Elias encoding actually begin from 1 to infinity. If you want 0, -1. If you want -1, -2. If you want -2, -3. If I want negative k, minus negative minus k minus bracket k plus 1. Right, it's just a very simple concept. But good thing is, right, your assignment asks for Lambert-Sieve SS, right, LZSS, and you realize your LZSS, right, the 0 and the 1s here are actually bits. They are not numbers. Okay, so when you do your LZSS, right, if you see here, they are actually bits. They are not numbers. Okay, so A will be big, A will be big, only A will be Elias and Elias, right? So what I highlight is your Elias. Okay, let's highlight it properly. Elias, right? And you realize your offset and your length will be at least 1, right? Your offset and your length will be at least 1. Okay, so because your offset and your length will be at least 1, your Elias encoding, you do not need to perform your shifting in your assignment, but in your exam, you may need to perform shifting, right? So it's something for you to be aware of. Okay, so that's all for Elias encoding. Hope it has been useful, right? I've covered a few tricks and shortcuts. The tricks and the shortcuts is mainly L, right? The whole shifting thing. Whew. Okay, that's all. Thank you and bye.